Our first homework question says the sum of two numbers is 24. The product of the same two numbers is 143. Find the two numbers. We'll start by designating x as the first number and y as the second number. Let's break these two questions at the top into two separate, easy to digest equations. So it says the sum of two numbers is 24. Well, sum means to add. So basically what they're saying is, let's take x plus y and set it equal to a value of 24. So there's our first equation. And then it says the product of the same two numbers is 143. Well, the product means to multiply. So we can take x times y and set it equal to 143. Now in our expressions, x times y would be usually rewritten as xy. So we'll say xy equals 143. Now in these particular problems, it's telling us that we don't have to find the actual solution to these. But since we have two equations, let's go through the motions anyways, graph these two equations, and we can see that we have the following intercepts. Now this is a bit of an exception to our usual graphing. We actually have two solutions here, and the reason why is x plus y could be any of the same two numbers. It could be 11 and 13, or it could be 13 and 11. Either way will work. It doesn't matter, which is why the graph has given us two solutions. The SPSS Student Council held a raffle and sold 480 tickets. Students were charged $2 per ticket and teachers $5 per ticket. Total ticket sales were 1,560. Determine the number of teachers and the number of students who bought tickets. Now once again, we'll take this and separate it into two separate equations. To begin with, we'll set x to represent the number of students and y the number of teachers. So the first part of this question tells us that the total number of tickets sold was 480. So we can say that x plus y equals 480. Every ticket sold was either going to be a student or a teacher. So it has to be either an x or an y, adding up to 480 tickets. We know that the students pay $2 and the teachers pay $5, and the total ticket sales was 1,560. So we can take the x value, multiply it by 2, add the y value, multiply it by 5, and that will give us the total ticket sales amount. So we can say something like 2x plus 5y equals 1,560. So x times the number of students paying $2 plus y, number of teachers paying $5, adds up to 1,560. Another way of stating the problem, the equation still is 2x plus 5y equals 1,560. Again, we don't need to complete any more. We've done everything the question asks, but if we did graph it, we would see that the graph intersects at the point 280, 200. 280 represents the number of students, 200 represents the number of teachers. In a hockey arena, rink level seats cost 3 times as much as seats in the upper level. If 5 seats at rink level cost $112 more than 8 seats in the upper level, find the cost of a seat at rink level. We'll start with our usual declarations. R representing the cost of a rink level ticket, and U representing the cost of an upper level ticket. Now, the rink level seats cost 3 times as much as seats in the upper level. We can say 3U equals R to represent this fact. 5 seats at rink level cost $112 more than 8 seats in the upper level. This is a little bit more complex, so we'll draw a little diagram to help us make sense of this. So we've got our 5 rink level seat tickets and our 12 upper level seat tickets. And they're telling us that the 5 seats at rink level cost $112 more than the 8 seats in the upper level. We can model this as 5R equals 8U plus 112. Once we have these two equations, we can graph them if we'd like to, though the question doesn't call for it, and see that an upper level seat would cost $16 and the rink level seat would cost $48. Jared has $3.85 in dimes and quarters. There are 25 coins in all. How much of each type of coin does he have? So our declarations can be let D represent the number of dimes and let Q represent the number of quarters. So we know there are 25 coins in all, so D plus Q will equal 25. Now dimes are worth 10 cents and quarters are worth 25 cents. So these dimes and quarters have to add up to a value of $3.85. So we can write 0.10 dimes or 0.10 D plus 0.25 Q equals 3.85. Once again, when these are graphed, we could see that we would have a total of 16 dimes and 9 quarters. And you can check your answer. 16 dimes would add up to $1.60. 9 quarters would add up to $2.25. Add these two together, giving us a result of $3.85. Read the following word problems carefully. Again, we do not need to solve these problems. We just need to list the equations or model the equations that the scenario represents. The sum of two numbers is 13. The product of the same two numbers is 40. Find the two numbers. As always, we'll start with our declarations. X can represent the first number. Y will be the second number. It tells us that the sum of two numbers is 13. Sum meaning addition. So we can say X plus Y will equal 13. It also tells us the product of the same two numbers is 40. Product meaning multiplying. So we can say X times Y equals 40. Or more common in our equations, we would write that X times Y as XY equals 40. The total cost of concert tickets for 2 adults and 4 students is $120. If student tickets are $15 each, determine the price of an adult ticket. Again, with the declarations, X can be the price of an adult ticket. Y will be the price of a student ticket. Actually, we'll probably end up using A for adults and S for students. So the total cost of concert tickets for 2 adults and 4 students is $120. Let's represent that with the equation 2A plus 4S equals 120. So 2 adult ticket prices plus 4 student ticket prices equals 120. Student tickets are $15 each. And this will simply be S equals 15. So there's our 2 equations. We graph them. We see that they intersect at the point 30, 15, telling us that the adult prices will be $30 and the student price will be 15. Yamir weighs 30 kilograms more than twice his younger brother's weight. If the sum of their weights is 120 kilograms, how much does each brother weigh? Here's our declarations. X can be the brother's weight. Y will be Yamir's weight. We're told that Yamir weighs 30 kilograms more than twice his brother's weight. So, if his brother's weight is modeled by X, we can say that Yamir's weight is 2 times X plus 30. We're also told that the sum of their weights is 120 kilograms. So X plus Y equals 120. There are twice as many quarters in a jar as there are nickels. Now this scenario can be very easy to get backwards. So I'm going to give you a little example using diagrams how we might be able to sort this out. So here we go, a little picture diagram of twice as many quarters in a jar as there are nickels. 4 quarters, 2 nickels. We could therefore say the number of quarters is the same as 2 times the number of nickels. In these equations, we want to get things equal. So in order to get the number of nickels equal to the number of quarters, we would have to multiply the number of nickels times 2. So we've got our 4 quarters equaling 2 times 2 nickels, which is also 4. We could model this with the equation saying Q equals 2N. The number of quarters equals 2 times the number of nickels. Now we'll be able to use that example in the following question. There are twice as many quarters in a jar as there are nickels. The total value of the coins is $2.20. How many of each coin are in the jar? Let N represent the number of nickels. Let Q represent the number of quarters. There are twice as many quarters in a jar as there are nickels, and we've already modeled that particular equation. Q equals 2N. We're also told that the total value of the coins is $2.20. Now, nickels are worth 5 cents, and quarters are worth 25 cents. So we could say 0.05 times N plus 0.25 times Q equals $2.20. Put another way, we could say 0.05 times the number of nickels plus 0.25 times the number of quarters equals $2.20. And when we graph that, we see the graph intersects at the point 4, 8, telling us that in this scenario, there would be 4 nickels and 8 quarters. And once again, you can test this just by multiplying 4 times 0.05 plus 8 times 0.25 and you will come up with an answer of 2.20. 3 times as many robins as cardinals visited a bird feeder. If a total number of 20 robins and cardinals visited the feeder, how many robins were there? So we'll make our declarations. R will represent the number of robins, and C will represent the number of cardinals. We're told that 3 times as many robins as cardinals visited a bird feeder. This can be modeled with the equation R equals 3C. 20 robins and cardinals visited the feeder, so 20 birds altogether. So we could say R plus C equals 20. Now that we have two equations, we could try and graph them, and we find an intersection point of 15, 5, telling us that 15 robins and 5 cardinals visited the bird feeder.